We are now looking at a teaching video on trigonometry. The subtopic is special angles. For the first part, we are looking at an isosceles right-angled triangle. So, if you look at this triangle, there is a right angle here that will make the triangle a right-angled triangle. And with these two sides of equal length, we also have an isosceles triangle. What it means is that these two base angles will be the same. If this is 45, that will be 45. So this triangle is both an isosceles as well as a right angle triangle. To obtain this side, we'll be using Pythagoras theorem. So we will take the square root of the square of this side, 1 squared, plus the square of that side, 1 squared. So we get the result square root 2. So 45 degrees is also the first quadrant angle, or we call it the basic angle. Now, this angle here, 135, and this angle here, 225, and this one, 315, can be obtained simply by some formula. So 315 is an obtuse angle, or is a second quadrant angle. So I can take 180 minus the basic angle. Here, 225, it is actually 180 plus the basic angle. And 315, well, that is 360 minus the basic angle. You can see from the basic angle, I can generate the second quadrant angle, the third quadrant angle, and the fourth quadrant angle. Now, for sine 45, I'm looking at this angle, 45 degrees. This side will be the opposite. This side here will be the adjacent. And here, the hypotenuse will be the longest side, which is opposite the 90. So for sine 45, I have opposite over the hypotenuse. So the value of sine 45 would be 1 over square root 2. The absolute value for these three will be 1 over square root 2. But we have to take care of the sign. So we have to go back to the idea of the 4 quadrants. Sine the first quadrant angle will give me a positive value. Sine of a second quadrant angle will give me also a positive value. Sine of a third quadrant angle will give me a negative value. Sine fourth quadrant angle will give me a negative value. So this is a second quadrant angle. So sine of a second quadrant angle, I have a positive value. So that would be the same as 1 over square root 2 of the sine 45 degrees. Then for this one, I will have to consider negative sign, 1 over square root 2. Then for the fourth one, sine 350, because this is the fourth quadrant angle, sine value is negative. So you can see by taking the basic angle of sine, I can generate 3 other values. Now we look at another trigonometric function, cosine. So the same arrangement, an isosceles right angle triangle. So when I look at cos 45 degrees, I'm looking at adjacent over hypotenuse. So the value would be 1 over square root 2. when I look at the 4 quadrants, sine of a first quadrant angle would be a positive value. Sine of a second quadrant angle would be a negative value. Sine of a third quadrant angle, a negative. Now, I may have told you sine, but it's cosine third quadrant angle is a negative value. Cosine fourth quadrant angle is a positive value. So what it means is that the absolute value for all these 3 will be 1 over square root 2. But we have to consider the negative sign. So for second quadrant, I will have negative 1 over square root 2. For the third quadrant, I will have negative 1 over square root 2. The fourth quadrant, I will have just the positive 1 over square root 2. So also one thing to consider is that for this particular case, sine 45 is equals to cosine 45. Now we look at tangent, the other trigonometric function. So for tangent, we'll be looking at the opposite side over the adjacent side. So tangent 45 would be 1 over 1. That would just give me a final value of 1. Now this is a second quadrant angle, this is a third quadrant angle, and the fourth quadrant angle there. So looking at the 4 quadrants, tangent the first quadrant angle is positive, tangent the second quadrant angle is negative, tangent the third quadrant angle would be positive, tangent the fourth quadrant angle would be negative. So the absolute value of these 3 functions here with the second quadrant, third quadrant, fourth quadrant angle will be 1, 1, 1. But I have to take care of the sign. For second quadrant angle, tangent 135 should give me a negative value. So I have negative 1. And tangent 225 degrees, that is a third quadrant angle, will give me a positive result, 1. And for the fourth one, I should get a negative value, so negative 1. So for the part 2, we're looking at part of or half of an equilateral triangle. So what I mean by that is this is only half of an equilateral triangle. A full equilateral triangle would be a triangle like this, with all 3 sides the same length. Now if I drop a perpendicular line down from the vertex of the equilateral triangle all the way down, it will actually bisect the base. I should have 2 units for the base, but now 1 unit is halved. Using Pythagoras theorem, I can work out this perpendicular height, which is square root 3 units. So this will be 60 degrees, that will be 30 degrees. It was an angle of 60 degrees. By having this perpendicular line there, it bisects the angle into 30 degrees and 30 degrees. So we are now looking at sine. So it will be opposite over hypotenuse. So for this particular case, I have a value of square root 3 over 2. You can recall For sine, it's only the first two quadrants that I will have the positive value. So that sine 120 will give me square root 3 over 2. And sine the third as well as the fourth quadrant angle will give me negative results. So I just have a negative square root 3 on 2. Here, negative square root 3 on 2. Now we are looking at cosine, cosine 60. So when we consider cosine 60, we are looking at the adjacent side over the hypotenuse. So in this case, cosine 60 is just half. Now these are the angles generated from the basic angle. 180 minus 60 is 120, 180 plus 60 is 240, and 360 minus 60 is 300 degrees. Now we know that cos value will be positive in the first as well as the fourth. So the second and the third quadrant for cos will be a negative value. So I will have a negative half here, negative half, and finally cos 300 degrees will be half. Now we are looking at the 60 degrees for tangent. For tangent 60, we take the opposite over the adjacent. In this case, it will be square root 3 over 1. So the value is just square root 3. We know also the absolute value for these 3 would be square root 3. Looking at the fourth quadrant, the third quadrant angle, 240, if I take the tangent of that angle, I will get the positive value. So the other two will have to be negative. So I have negative square root 3 for tangent 120 degrees, and I have square root 3 for tangent 240 degrees, and negative square root 3 for tangent 300 degrees. So we mentioned that if this is 60 degrees and that is a fixed right angle, then that will be 30 degrees, 30 degrees. Because all three interior angles would add up to 180 degrees. Now, this one unit here is the opposite side, and here the hypotenuse, because that is opposite the right angle. So when I'm looking at sine 30, then I'll take the opposite over the hypotenuse. So 1 over 2, that gives me a value of half. And all these three angles are generated from the basic angle 30 degrees. So second quadrant angle, third and the fourth quadrants. So for sine, only in the first two quadrants you will get positive value of sine. So half here, and this is half as well. As for sine, the third and the fourth quadrant angle, I have negative values. So you can see, by just understanding the four quadrants, I can generate more values for the corresponding second, third, fourth quadrant angles. Now we look at cosine. Cosine, well, that is the adjacent side if I'm looking at this angle, 30 degrees, and this is the hypotenuse. So for cosine 30, I will have the adjacent side, square root 3, over the hypotenuse, 2. So for cosine function, it's only the cosine of the first quadrant angle and the fourth quadrant angle, you will get positive values. The rest, the second quadrant, third quadrant of the sine, well, that will be negative. So I'll put down square root 3 on 2 here, minus or negative square root 3 on 2, negative square root 3 on 2. We now look at tangent 30 degrees. For tangent, I'm looking at the opposite over the adjacent. So tangent 30 degrees would be 1 over square root 3. And tangent of the first quadrant angle, tangent of the third quadrant angle, I get positive values. So 1 over square root 3 here, 1 over square root 3, also for tangent 210 degrees. As for the second quadrant and the fourth quadrant, tangent, the angle, would give me a negative value. And as we said before, the absolute values would still be the same, so just adding a negative sign to this. Negative 1 over square root 3, negative 1 over square root 3. For part 3, then we look at the basic trigonometric graphs. So the first one that we want to look at is y equals sine x. Now these are the values that we can find, or we can use the graph to help us remember those values. So y equals sine x. If I take this as 1 and this as negative 1, here is how the sine graph will look like. Now from there, you can see that sine 0 degrees is just a 0. Sine 90 is 1. Sine 180 is 0. Sine 270 degrees is negative 1. And sine 360 degrees is just a 0. Now, if you put in whatever else that we have talked about just now, in between we had sine 30 degrees, we had sine 60 degrees, then here we had, we also had 45 degrees. So the rest of it, so we actually have a complete tables of those values that you normally have to commit to memory. So there were 1, 2, 3, 4, 5, and then 3 in between, that make it 8, 3 in between, 11, 3 in between, 14, 3 in between, 17 angles of the sine that you have to remember. Now we look at cosine graph. I will take this as 1 and here negative 1. The cosine graph goes like this. Now this graph, if you have it in your head, will help you remember these values. So cosine 0 degrees is 1, cosine 90 degrees is 0, cosine 180 degrees is negative 1, cosine 270 is 0, cosine 360 is 1. Now let's look at the tangent graph. Well, if we just look at tangent 0 degrees, that is a 0. Tangent 180 is a 0. Tangent 360 is a 0. And if we look at x equals to 90 degrees is a vertical line, and x equals to 270 a vertical line, you realize that the tangent graph will not touch these two lines. It will go very close to it, but will never touch the line. So for these two values, we have this sign here. But if you try to key in tangent 90 degrees in your calculator, it will give you mathematical error. What it means is that at this point, the graph is undefined.